alternate angles. That they are hope my voice is audible. Yes, Cedric. Property for the alternate angles.
Ma'am, alternate angles always occur on the opposite side of the transversal and they're equal.
And they're equally good. Okay, so yes, Abraham, can you tell me the property for interior angles?
Interior angles appear on the interior of the transversal and they always add up to 180.
Yes, interior of the transversal, and their sum is 180 degree. Angles that fall on the same side of the transversal interior in the parallel lines, their sum is 180. Very good. So today we are going to learn the verification for all types of angles. Okay, for corresponding alternate and interior angles, we will see their verification. So first,
I didn't hear that. What are we going to do?
verification for corresponding alternate and interior angles.
Verification.
Yes, verification. Corresponding angles. So let's talk about it. Now we are going to draw a diagram and check. Okay, we are going to draw a diagram and verify. So I'm going to give you the steps. Okay, and you guys can follow it. All right. So step one is draw a line. Okay, draw a line and name it L1. Draw a line L1. Done.
Yes, ma'am.
Okay. Everyone, hope everyone is done.
Ma'am, 1 minute, please.
Okay. Next step, mark 2 points on it, A and B. A and B. Mark 2 points. On it, A and B. Okay. Now, hope you guys have
Oh, no.
brought your protractor.
Does A
Yes,
and
it does.
equal distance?
Does A and B have equal distance? No, you can keep any distance between A and B. Okay, you can put any distance between A and B. Just don't make it too close, okay? Just not too close. All right, leave some gap and then mark 2 points A and B. Now get your protractors. Okay, hope you guys have it. So it's okay, Simon. You can practice when you reach home. Yes. So get your protractor. First, place your protractor on point A. The center of it, the center of the protractor, place it on point A. Okay, place it on point A. And now see where 50-degree angle is forming. See where 50-degree angle is forming. Okay, now where it is forming that line above the protractor, put a dot there. Okay, put a dot there. Like this. Okay, put a dot there. Now join that point where you are getting the 50-degree angle to the A point. Okay, join that point from there to the A point. Okay,
So
and
basically draw a 50-degree angle from the A point.
yes, that is right. A
Ma'am,
50
50
degree,
degree or 60 degree?
50 degree, 50 degree.
So all the time we have to use only 50 degrees?
Um, no, Simeon, you can use any of it. This is an example. Okay, next example, we will use 60 degree. Okay, join it like this. Yeah. So this angle will be 50 degree. Hope everyone is getting a 50-degree angle. Measure it. Yes,
Got 50
Abraham.
degree.
50-degree you are getting. Okay. Edric getting 50 degree.
I cannot find my protractor, ma'am.
You cannot find your protractor.
Because I'm lazy not
Okay.
the right place.
So, Abraham, you can, I think,
He logged out.
yes, lock down. Okay, he's rejoining. So 50 degree here people get, okay? Same thing, repeat it with point B. Place your center of the protractor at point B and mark a dot here at 50 degree again. Yes, Abraham. So if you are not able to find the protractor right now, you can just do it with scale, okay? And write the steps in short. Whatever I'm saying, the steps, write them in short at the side. So later on you can do it. Simeon, you too, okay? Simeon as well.
Yeah. Is there a particular distance that has to be there between point A and point B?
Point A and point B, no. No particular distance. Okay?
So
Yes.
like any distance is fine.
Any distance is fine. According to the line that you have made, according to the line L1, any distance you guys can put between point A and point B. Okay. So now from point B, put your center of the protractor at point B and again make 50-degree angle. Once again, make a 50-degree angle. Put a point here. Okay, mark 50 degree and then join it to point B. Join it to point B and cut it through B below. Okay, below B.
Then ma'am, I got 50 degree.
Okay, that's the banana. This is 50 degree again. Okay. Now the thing is, next what we have to do, we have to place a set square along one line and sliding. Okay. So how do we place the set square? 1 minute. Do we have a triangle?
Sorry, I didn't hear that. What did you say? Well,
Hope you guys are having your set square. Set square. Set square we are going to use.
No, ma'am, I don't know what that is.
It's all right. This is the device. That's the set square. It's like this, and this triangular shaped thing that's in your geometry box. Okay, this is the
No,
set.
ma'am, I don't have that.
Okay, that's all right. So you can note it down. Simeon, you too. You can just write it. Okay. And I am going to stop sharing this screen and I will show you people how it is placed. Yes, Simeon, you can do it later, definitely. For sure, you can do it later. Okay. I am going to show this screen how the set square we will place. Okay. Just give me 1 minute.
we can't see your screen.
Can you see the diagram here?
Yeah.
Yes. So can you see the set square that is placed here? Like it was important to show you this diagram so that you know how to place the set square. This scale part,
Oh, so you're going to put the set square to mark like that is same.
yes, to mark that if the distance between line L2 and L3, we will name the two lines L2 and L3. Okay, name it L2 and L3. And this is how you put the set square. Okay, and then we see that if the perpendicular distance between both the lines are same or not. Okay, that is this distance between the lines here. And this
Ma'am,
distance, yes, Hedrick, you can
ma'am,
measure
which set
from
square should we use? Ma'am, which set square should we use?
which set square should you use? Try the longer one.
This one?
Yeah, yes, that this one.
But in the picture, it's showing the other one, the smaller one.
Try the smaller one, Hedrick.
Picture in the picture is showing the smaller one.
Yeah, try the smaller one. Try the smaller one. Okay, and with its scale that's mentioned on the set square. Okay, measure your Cedric. Okay, and tell me that what is the distance? Like set squares on its sides, scale is mentioned, scale is given. So measure it from your set square. Measure the distance from your line L2 and line L3. Here and here, measure the distance.
Ma'am, I got 2.75.
2.75. Okay, that's basically 2.7. Little bit between 2.7.
And 2.8.
Okay. Yes, 2.8 almost. So now, Edric, if you measure it like 1 minute, I've cleared this all. Okay. And if you place the set square at this point, okay, here, and if you measure from here, or if you place the set square here, and if you measure from here also, or if you measure it from here also, you will get, in all three cases, you will get 2.75 distance. Okay. Same thing. Why?
Why
Because
did you write 2075?
This is the point 7. Okay. Yeah. Now, so what it is that line L2 and L3 are parallel. Okay. Because the angles that we constructed are both equal. Alright, both are 50 degrees. So the lines with which we constructed will also be parallel. Okay, similarly, when we make parallel lines, the angles that are formed are also equal. Okay, so hope how we are constructing is clear. Steps of construction. Anaya Sunyan. Hello. Hope the steps of construction is clear to you.
Yeah, I wrote it all down.
You wrote it all down. Okay, good. So So our diagram that will be formed will be like this. This is line L1, L1. Here your 50-degree angles will be made. 50 degree and 50 degree. Okay, because this is point A and this is point B. Okay, now your lines you can name them L2 and L3. L2 and L3. Okay, so this is how this figure will be constructed to prove that corresponding angles which are made when two parallel lines are intersected by a transversal, they are equal. Okay, so you can write it down. Hence, if a transversal if a transversal intersects two lines in such a way that pair of corresponding angles are equal, then the lines are parallel. The lines are parallel. Okay, so L2, L2,
It could also be like if there is two parallel lines and one perpendicular line that's perpendicular to both of them. And if it is perpendicular to both, then they are parallel.
if it's perpendicular to both of them, then what did you say after it?
Then they are parallel
Then they are
because
parallel.
it is creating 90-degree angles in both.
Yes, Neil, that is right. Okay, that's correct. Now L2 is parallel to L3 and angle A is equal to angle. Done, guys?
Yes, ma'am.
I'm done copying.
Done.
Oh, okay. Okay. All right. Next, we will see how do we prove the alternate angles. Okay. Again, we'll be going to construct a diagram. Okay. You can write down the steps or you can follow. And if you do not have the set square or the instruments right now, just note it and make the diagram. Okay. Afterwards, when you get the instruments, you can measure it out. Okay. Yes. So let's try out for verification of alternate angles. Alternate angles. Okay. Now, step one is the same. Just draw a line segment or a line. Okay. Draw a line. Name it L1. Okay. Or you can name it anything else, whatever you want to.
Does this also have a line segment inside?
Does this also have a line segment inside? Yes, it does. Okay. I'm naming it L1. L1. Again, mark 2 points on it, A and B. Mark 2 points, point A and B, on the line, on this line L1. Okay, let's mark 2 points. This is E and this is B. Okay, mark 2 points A and B. Done. Okay.
Yes,
So
ma'am.
from A. Oh, okay. Now take your protractor, put it on A point, the center of the protractor, the midpoint of the protractor on A, and put a dot above the line that's giving 60 degree. Okay. Somewhere here, the line that's giving 60 degree, put a point there, okay, and join it, cutting through A. Okay, that is your 60-degree angle.
$50 or 60 degrees?
60, 60, 60, 60 degree.
Done, ma'am.
Done. Okay. 1 second. Just do it. Like it's okay if you have extended it also. It's okay. All right. If you have made the whole thing also, but like if you haven't made it yet, you can just do it till line A, till dot A. Okay, till dot A you can do. Now listen very carefully that first mark it 60, mark this angle 60. Okay. Now from B, what will we do? Turn your copy like this. Turn your notebook upside down like this. Okay. The angle that we're going to construct from B will be constructed below the line L1. Okay. Angle 60 from B, which we will construct it below L1. Okay,
I didn't
that's,
understand.
you didn't understand? It's okay. You can turn your notebook like this. So B will come up. Okay. So when B comes up, put your center of the protractor at B and mark 60 degree like this. Okay. Or you can turn the
Can
protractor
you
and
show
put
us how to do it once more on the screen?
on the screen. All right. So here, when you placed the protractor, you kept the center. Here was the center of the protractor. You placed it like this, right? And here was 60. Okay. So now when you are doing for B, this is for A point I showed. Now when you're doing for B, you can just turn your protractor, okay, like this. And you can place it here like this. Okay, your protractor. Take the center,
So
the
both for
center of the
A and for B, we have to draw 60 degrees like that.
yes, yes. For A and for B both we will draw 60 degree. But for A it will be above the line. For B it will be below the line. Okay, for B, it will be
Ma'am,
below the line. Yes,
so B
Ananya.
has to be in the center of the protractor.
Yes, B has to be at the center
B
of the
has
protractor. Yes, center of the protractor. Reverse the protractor. Turn the protractor like this, okay, and then put. So your 60 will come somewhere here. Okay, it will come somewhere here on the protractor. Okay, somewhere here it will come. Mark that point. Okay, put a dot there where the 60 line is going.
Ma'am,
Dot, yes, Edric, and then join it. B and the 60-degree dot. Join it.
done, ma'am.
Done. Okay.
Yeah, I'm done.
Done. Okay.
Done, ma'am.
Now extend the lines from the A point where it was cutting. Extend it further, and from the B point also you can extend it with dotted lines.
You have to or you don't have to?
You have to. You have to extend it with dotted lines. Okay. And mark
Ma'am,
this 60 degrees. Yes, Edric, show me. Yes, that is right. That's correct, Edric. Okay, so here will be the 60-degree angle of B that will be formed at B. Okay, 60 degrees that will be formed at B. And you can extend it like this. The B line, okay, you can extend it like this. Okay, and the A line, you can extend it like this. All right. Now, name them, both of the lines. Name
yes,
them both. Okay, so this is L2. I'm naming it L2. And this one I'm naming it L3. Okay, L2 and L3 I am naming. All right. So now angle A, that is 60 degree, that's above the line L1. And angle B 60 degree below the line L1. Can you see that they are forming alternate angles?
yes, ma'am.
Yes, they are forming alternate angles. Okay, so hope the construction part is clear, how we are constructing it.
Yes, ma'am.
Okay, so mean all the steps are clear.
Yeah.
Okay, now take the set square. Okay, and again place it like that. Okay, like the previous one. The scale thing over here. Okay, I'll draw and show you.
Between the dotted and the straight one.
Yes, between the dotted and the straight one. I'm making a set square with the red lines.
Ma'am,
Yes, Cedric.
4.9.
4.9. Okay. So this way we will make the set square here. Okay. And it will measure the lines here. Okay. And here. Alright. So if you measure the distance from this point, or if you measure the distance from this point, or any other point, we will get that the distance is the same. Okay, Edric, it will be, you will be getting 4.9. Okay, again, why? Because when alternate angles are formed between two parallel lines, the alternate angles are equal. Or when two alternate angles are formed using two lines and they are equal, then the two lines will be parallel. Okay, this is the
I didn't
property of.
hear that.
You didn't hear that? Okay, I'll repeat it. So if two alternate angles are forming with two parallel lines, then those two alternate angles will be equal. Okay. But in this case, what we
Okay,
did,
now I
we
got it.
constructed. You got it? Okay. So we constructed two alternate angles that are equal, and then we join them. So the lines that will be there, which have two alternate angles, those lines will also be
Ma'am,
parallel. Okay, and vice versa. Yes, Andrew.
ma'am, it's not 4.9, it's 4.4.
4.4. Okay, 4.4.
For all of them, it is 4.4 only, not 4.9. It's
All
4.4.
of them. All of them. All right. So all of them it will be 4.4 only. Why? Because both lines are parallel. So the
Ma'am,
distance that's there here, the distance which will be there here between L1, L2 and L3, and the distance here between L2 and L3, all of it will be equal, okay?
ma'am,
Because both are parallel lines.
So here,
Yes.
the you can use like any a set square, or you should use a particular set square.
in,
I think any set square you can
in,
use. It's just for the measurement. Okay. And yes, any doubts, anyone?
ma'am,
Yes, Anshul.
okay. So, so the alternate angles are equal, then we can confirm that L2 and L3 are parallel lines.
Parallel lines. Yes, that's right. Because angle A and angle B, which are alternate to each other, are equal. Both are 60 degree. So L2 and L3 are both parallel lines. Okay. Okay. So now write one sentence. Can I erase the diagrams?
Yes, ma'am, I'm done. Okay, ma'am.
Okay.
Done.
Okay. Simeon, hope you have
Yes,
made it. Okay.
I made a rough one.
You made the rough. Okay. You can just go home and try it out. Okay. Try to do the fair thing. So, alternate angles.
Didn't we just finish alternate angles?
We finished the alternate angles. We are just doing, like the end thing that I just explained. We are just going to write it. Okay. That's it. We are finished with it. We are just going to write it. That if a transversal intersects other two lines, other two lines in such a way that that pair of alternate angles are equal, alternate angles are equal, then the lines are parallel. Then the lines are parallel. Okay. So this is the we did the verification for alternate angles. Okay, we actually constructed and saw verified that how they work, how they are equal when they are constructed in between two parallel lines. Tomorrow or the next class, tomorrow I guess we're having the math test. In the next class, we will see tomorrow, maybe day after tomorrow, like science math tests are there. So whenever we'll have the next class, we will see the verification of interior angles. Okay, how when interior angles are made on the same side of the transversal, when they are made interior angles, like inside the two parallel lines on the same side, their sum is 180 degrees. Okay, we'll do its verification. And that's all for the math class today. Okay,
Okay.
and 5 minutes break, and then I'll see you in the science class.
Ma'am, I have a question, ma'am.
Yes, Amanda.
The Chapter 9 test papers, when will the results come out that you
Chapter
haven't
9
sent it
test.
yet?
I'll share it soon, okay? Because I've been occupied a little since the last few
I
days. I'll
understand,
try
ma'am.
my best.
I was just asking.
Yes, yes. So probably by today, like I'll try my best to check it up today and share, okay? By today evening. All right.
By
So
today evening.
yes, today evening.
Okay.
Okay. Yeah. So then science class in 5 minutes. Okay, Adric, see you in the next class. Bye.
Bye, ma'am.
Bye. Just give me 2 more minutes, guys. Till then, open up the chapter and please revise what we studied in the last class. Just go through it. Let's begin. We did magnetic effect of electric current in the last class, and we are going to see the chemical effect of electric current. Now, here's an activity where salt solution has been applied to the two ends of electric circuit. Now, how does the bulb get emitted? Light of bulb means the electronic circuit is not broken. This means it keeps on passing with salt solution. This tells us that salt solution is a good current of good conductor of electric current. Okay. Now what happens, guys? Chemical effect of electric current means that what happens when we apply something of a chemical nature to the ends of the electric circuit, what will be its effect basically? So it's talking about that. Okay. Now they took salt solution. Okay. They took a salt solution and then they put it on the two ends of an electric circuit. Okay. Here are is an electric circuit. Okay. They put it on its ends. Okay. Here. Okay. So now when they put the touch button on, that's when the circuit is connected. What happens that even though the salt solution has been put there, has been applied there, the bulb will light up. Okay, the bulb will light up. Alright, why? Because like even through the salt solution, electricity is passing. Because it is a good conductor of electricity. Okay, because the salt solution is a good conductor of electricity. But if I apply any liquid, okay, that is not a good conductor of electricity, what happens then? What happens that light will not, the bulb will not emit light. Okay, the bulb will not emit light. Okay, why? Because that solution which I applied to the ends of the circuit, though that solution is a bad conductor of electricity. Okay, so light will not allow the electricity to pass through it. It will not allow the electricity to pass through it. Okay, so that way we can determine which substances are good conductors of electricity and which are not. Those liquid by which the bulb does not get emitted are weak conductors of electricity. Okay, so you can try it out with lime juice. Okay, bulb it's lighted because it's a good conductor. Then we have vinegar, tap water, oil, and milk.
Lime juice and vinegar are good conductors, right? But tap water, oil, and milk are not.
Yes, tap water, oil, and milk are not.
Ma'am, where are we? What is this?
Where are we?
Chapter 14. What part?
14.4.5, that's chemical effect of electric current.
Okay, thank you.
This part. Yeah. Yes. So that's right, Samyan. Lime juice and vinegar are a good conductors, so the bulb will light up. But tap water, oil, and milk are bad conductors of electricity, so the bulb will not light up. Okay. Then next, one more activity we are having. Take out the carbon rods of any two disposed of or waste cells. Make their top ends clean by using trick paper. Now join them with a battery made up of two cells. Carbon rods will do the work of electrodes. Positive terminal rod is known as positive electrode or anode. The negative terminal joint rod is known as negative electrode or cathode. Electrode can be made up of copper, metal, or any other
1
metal.
second, can I just write that down?
Yes, Sunil, you can write that down. Okay, so two carbon rods we have here. Two carbon rods we have here. Okay, and they are joined together. Okay, with battery made up of two cells. This is battery. Okay, and these are carbon rods. Okay, and now they have joined a wire to it. Okay, with the battery, they have joined a wire that is connected with the copper rod. Okay, so they are having two terminals. This is the positive terminal. Okay, here is the positive terminal, and here is the negative terminal. Negative terminal. Okay, so the negative terminal joined rod. Okay, first this is the rod that is joined with the positive terminal. Okay, this is the rod that is joined with
Which is the positive terminal?
this one.
What on it?
Left one is the
No, I couldn't see it.
positive.
I couldn't see it.
You couldn't see. You couldn't see. Okay, it's okay. Yes, this is a battery. These are the rods. Okay, copper rod. Okay, and I'll just put it down. Okay, this is the positive terminal. This is the positive terminal. Get plus sign is there. Positive terminal. Okay, and this where negative sign is there is known as negative terminal. Okay, Now, can you see a thin wire that is that's joining the battery with the copper rods? Okay. Now, this wire is joining the battery with the copper rods. Okay. So, what's happening? This is this plus sign, I'll show you. This plus thing is joining with this battery, okay, and this minus, that is negative terminal, is being joined with this battery. So this point where the positive it's joining the positive terminal is known as what? Anode.
So this one is anode and the right side one is cathode.
Cathode. Yes. And this one is cathode. Okay. The positive one, the copper rod which connected with the positive terminal is the anode, and the copper rod which is connected with the negative terminal, the battery side, is the cathode. Okay. Hope the diagram is clear.
Yes.
Okay. So we will see how it works. Now, electrode can be made up of copper metal or any other metal. Okay. It can
But
be. It will
why does
also.
it say copper metal or any other metal?
Why does it say copper metal or any other metal? See, now what happens? Why does it say that? See, now here is the, like, it's talking about this wire, okay, and this part of the copper rod. Okay, so it can be made with copper metal or any other metal. Yes, okay, can be used to make it. And the anode that I explained, that is this part, is also called positive electrode. Okay. And this cathode, that is this negative terminal part, is can also be called as the negative electrode. Okay. Or cathode. Now, electrode can be made up of copper metal or any other metal. Put both electrodes in a glass box which is full of water. You found few gas bubbles in both the electrodes. Actually, these are bubbles of
What does
oxygen
it
and
mean by
hydrogen
gas
gas.
bubbles in both the electrodes? Like
Gas
be inside
bubbles,
like the
I think it will be inside the water, near the rods. Where rods are immersed in it. Near that, I think there will be bubbles. Okay. Now, these are bubbles of oxygen and hydrogen gas, which have built by the breaking of water molecules due to the electric current. Okay, so here near the copper rod, there will be bubbles. Okay, why? Because the water is having molecules, all the three substances, the solid, liquid, and gas are having molecules. Okay, so water is also having molecules. Now, what happens that when the electric current flows in it, okay, when the electric current flows in the copper rod that's immersed in the water, that electric current gets in the water, okay, that's around the rod and breaks the molecules apart. Okay, breaks apart the molecules of water. Okay, due to the electric current. The electric current passes through it. It will break apart the water molecules due to which the bubbles arise. Okay, this chemical reaction is seen when oxygen gets collected on anode and hydrogen gas gets collected on cathode. Okay, oxygen gets connected on the positive terminal, that is anode, and hydrogen gas will be collected at the negative terminal, that is the cathode. Okay. Now, if we add copper sulfate in this water, then copper molecules will start collecting on cathode. Okay, so copper molecules will start collecting on cathode. Okay, now if we add copper sulfate in this water, then copper molecules will start collecting on cathode. Okay, now if we add copper sulfate in this water, then copper molecules will start collecting on cathode. Okay, now if we add copper sulfate in this water, if we add copper sulfate solution in this water,
So like you just
okay,
mix it with the water.
yes, you just add it in the water and mix it. Then the copper molecules will start collecting on cathode. This will build a thin layer on electrode. Okay, these are the electrodes. We will build a thin layer on it, and this is also this characteristic is used in electroplating. Okay, you guys know
What's
about
electroplating?
electroplating is basically a thin layer of copper that is put on, I think it's basically put on the metals or something. Okay, this is similar to like to protect it from getting damaged or rusted or any chemical reactions. Okay, the plating is
Because
done.
copper is free from rust, like it doesn't get rusted.
Yes. Yes. Okay. So this reaction is used in electroplating as well. Okay. Now, electroplating we have. Okay. Like electroplating we have. Now, what happens? It's a procedure where a layer of a metal is built on other metal. Like the iron handle of a cycle has a layer of nickel, and silver ornaments have a layer of gold, etc., to protect them, okay, from corroding, from rusting. Okay, so yes, Simran.
But why does silver ornament have a layer of gold to protect it? Why
Why,
can't it have like
why doesn't it have like any other metal plating? Okay, because gold plating is mostly because like to enhance the look of the ornament as well. Okay, gold plated ornaments they are. Okay, it's not pure gold, it's just a plating of gold so that it gives a look of gold ornament. Okay, and also it has a longer life, longer duration. It can go on and it will stop rusting and corroding the silver ornament. Okay, or the black, it becomes like black, some metals. Right, so to stop that also, gold plating on ornaments is done. Okay. Then the use of chemical reaction of electric current is known as electroplatation. Electroplation. Okay. And like this reaction that we just studied now, it's done using copper sulfate. Okay. On the metal. All right. Now, metal or item on which layer is supposed to be made is added with positive terminal, and the metal which is used for thin layer solution is added with electrode to produce electric current. Okay, this is talking about the same thing that we did. Okay, electroplating is done on iron nail. Okay, positive and negative terminals are there. This is the iron nail, and this is the copper electrode. Okay, this is copper electrode.
why does the right side look like it's like the bottom end is pointed?
Bottom is pointed because of the nails. Nails have a pointed bottom, pointed edge, right? So yes, it is pointed. Okay,
No, why
and this
was
is
oh it's a nail.
it's a nail. Yes, it's a nail, and
I
this
thought
is
it was
copper.
something else like a normal like
No, no, it's a nail. Okay, this is copper sulfate solution. Copper sulfate solution. It is okay. This is the positive terminal or the anode. Okay, and this is the negative terminal. Negative terminal or the cathode. All right. So the ions will basically the copper ions will basically collect at this on the surface of the nail. Okay, and thus will form a layer of it on the surface of the nail that will protect the nail from rusting. Okay, so the nail will be electroplated. Okay, using this chemical reaction, the nail will be electroplated. Okay, I hope electroplating part is clear to all. How electroplating is done. Hello. Hope this
I
helps.
didn't hear.
I was just asking if there's any doubt in it. It's clear to you all.
No, I got.
Got it? Okay. Just give me a minute and I'll just check if I can find out a video on the electroplating to show you all. Just one minute. Okay, this is good. So here they are going to put a spoon, okay? Going to do electroplating on a spoon at home, okay? They have added water and copper sulfate powder in it. So we have copper sulfate solution. Here's a battery and a copper wire. Okay, so the copper wire is attached. That is your basically copper rod, and they have left a spoon in it, and you can see that copper plating on spoon is there. Okay, and copper plating on coin is there. All right. So this is basically the
That looks like
copper.
fun.
Yes, Anaya.
I just said that looks like fun.
Yes, it's fun. Yes.
You could,
So
like, if you wanted to take a US penny or something, you could just make one out of aluminum foil, like if you're good at molding it, and then you could cover it with copper with this. And
yes,
everybody
like
would
this.
think you have an actual penny.
Mhm. Yes, that is right. You can try it out. You can try electroplating like this at home. Okay, so just be careful with connecting the battery. All right. Yes. So, any doubts till now? We have finished with this chapter. We have finished with the chapter and 14.5 index question video homework. Try it out. Okay. And then try the back
Book is
questions.
index questions. What?
14.5. 14.5. Okay.
Which index
14.5.
questions is
Right after the electroplating part. Okay. Just tell me your video has frozen for me. Can you hear me? Can you hear now? Yeah.
I can hear.
Okay. So 14.5 is the homework. And also, please try out the in-text questions, terminal exercises also. Okay. Let's also please try it out. Terminal exercises also. Please try it out. So with this, we have finished with this chapter. Okay, so this chapter is over. electric current and magnets. This chapter is over. I think we're having a network error somewhere. Yes. Next chapter is movable objects, force, friction, and motion. Okay. Movable objects we are going to talk about. We are going to talk about force. Then we are going to talk about friction and motion. Okay. We'll study about it. Static and motion we'll talk about. Okay. When something is at one place, it's known to be static. And when something is moving, it's said to be in motion. Okay. Then we will talk about the types of motion. Okay, we have different types of motions. We'll talk about length and measurement of distance. Okay, and we'll talk about force pushing. Okay, and stages
I
of
read this chapter.
You read this chapter. Okay, then that's great. That is great. Fiction we'll talk about.
But I didn't understand the dynamic part.
You didn't understand the dynamic part. We'll do the dynamic part. Okay, we'll try to do it together and learn it. So we'll stop here. Okay, we have pressure, kinds of friction, and everything. We'll continue this chapter in the next class. Okay, we will stop here, and I will see you guys in the next class. Okay, timing I'll upload in the group. Same timing it will be for the science and math class. Same afternoon timing, like not this timing, morning timing, but the next few days we'll give the afternoon timing. Okay.
Okay,
Okay,
ma'am.
then.
Thank you.
See
Bye.
you all. Bye.
The same timing in the morning.
No, afternoon time. Okay. Noon
Okay.
timing will be. Okay, guys. Then see you all. Bye.